Hello, so today we are going to take a look at this problem from day 17 of Leetcode 30-day challenge. The problem is called minimum path sum, and the problem says we have an n by n grid filled with non-negative numbers, and we want to find a path from the top left to the bottom right that minimizes the sum of all numbers along its path. And we can only move down or right at any point in time. So by seeing this minimization here, that kind of tells us that probably trying some dynamic programming solution may help here. And so for that, let's just look at the maybe state, I think, the state of this. So at each point, what matters is the position, right? So position, this here is the position, and then sum so far, right? So these are the two things that will help us determine, go to the next step, right? So what I'm thinking is maybe we could just define a helper function here with I and j, and then with it has as a result the sum. Then at that point we could just return. We want to start from, I'll do minimization later because we'll have probably a lot of duplicate states, but first, when do we know we will be done, right here? So we will know we are done if we reach the bottom right. So that would be, let's just put here rows and columns. So rows would be the length of the grid, and column would be the length of grid 0. We should check the constraint. We don't have constraints, so let's just safeguard against, so if not the grid, right, then the sum would be just return 0, right? And so here, now we could check for I, if I equal to rows or g equal to columns, then at that point we know that we, sorry, not, actually let's first just check the boundaries, right? So if we want I to be in the right boundaries, right, which is 0, I, rows, and j to be also in the boundaries, so j, columns. So this is our, if we don't find that, we should just return 0. Now what should happen here? We can move either down or right, okay? So down or right. So basically down is just going one row. So we have, this is the first row, 0. So down is moving to 1. So it's kind of going I plus 1, and then right is going j plus 1, right? So here what we will do is we will need to call helper on I plus 1 to go down, right? And then another one on to go right, so that would be j plus 1. Now what should we do with both, right? We can either go down or right. We can do both at the same time, right? So what we want to do is we want to take the min of both, right? Choose the smaller one. And then return the value at that position. So that would be grid I j plus this, right? With this work. And then one problem is visiting the same place multiple times, right? We don't want to do that. So one thing we could do is, are the numbers always negative? Yep, and always positive. The numbers are always positive, right? So that means that going to through a number again will only increase the sum. We may need to have a visited set or mark visited numbers, but for now let's just try this and see if this passes. Okay, so it doesn't. We have expected answer 7, we got 5. So we got a smaller number than what's possible here. Yeah, the problem is I don't stop. I should stop only when I reach the end, right? And here I'm stopping at other positions that are not the bottom right, okay? So that's a problem there. So one way to avoid that is to have S here as the sum, and then that sum starts out as 0, right? And then here, what will happen instead is taking the min of S plus this, and here we can maybe return something that won't be the answer. And then here only if I is equal to rows minus 1 and j equal to columns minus 1, which means the bottom right corner, then at that point we should return S. Hopefully this would... Okay, this is still not good enough. So we want the bottom right corner, which means we want to take this path here. 1, 3, 4, 5, 6, 7, right? So I think this is right, because if it's not a path that should be counted, we should move on, right? I think, yeah, the problem is we are not counting the last row here, which is bad, so we should do this. Maybe we'll get time limit exceeded because we are not storing the visited set. Yep. Okay, so one thing I'm going to do here is so I'm going to put the value there, and then I'm going to set this to -1. And then I'm going to use the value here and the value here. And then after that, what I will need to do is check before. So instead of doing this, we could do if grid is negative. That means it was visited before. So just return this thing that won't allow this to be the solution. Yep, so it should be here. That's not working. Give us 9 here. Okay, actually I'm going to handle this differently. So let's leave this change here with -1. And instead what I'm going to do is memorize. So I will have this hash map here and check if ij is in memory, just return that. This way we won't ever duplicate same position. And well, like reaching this value from another place, so the sum should also be, we should take that into account. Well, if we can reach, I'm not sure if we need to take the sum into account. Maybe we don't. Let's try without it. And so we would get this, else we'll get this. Well, actually, what we can do is instead just initialize this, so collections default dict. Well, that would be 0. That's not what we want. Just leave it like that, and then return. Sorry, return this. Let's put this here. Okay, so it doesn't pass with the first test case. Okay, so let's try. Okay, so that looks good. Submit. Okay, so we get time limit exceeded again. This time very close to the last value. So is there anything else we should be doing? So actually, so I wonder if we could exit early, because the sum is. So actually what I'm going to do, I think, is just simplify this. This is a little bit too complicated. So let's get rid of this sum here. Let's just return the grid value. And let's get rid of this S here. That will be the return value instead of part of the state. And then we could just end up with this, taking the min of these two. And what we'll do here is add the grid value to the result. And not have this, not have this either. Let's get rid of this. This is not useful. And then what we can do here is, if to avoid checking here, we could just check at the beginning if one of them is equal to rows. It has to reach rows before exceeding it, right? And the same thing with columns. And so if one of these are true, we could just return. Now we want to return a maximum value, so it doesn't become the min here. And then we want to do this. So let's run this. Yep. So here we want to send just 0, and let's first just test without the long use test case. Okay, so that looks good. Now let's put this one. So that one looks good with this case. So let's try with a bigger one. Okay, so that one also passes. Yeah. So essentially it's just dynamic programming, but I'm using here the recursive approach with memoization. And yeah, pretty much just memoizing the solution. My state is just I and j, and then I'm returning the sum so far and picking them in every time, right? And yeah, that's pretty much it for this. I think. So let's first submit. I mean, I just ran it on the test cases that failed before, but let's submit it. Okay, so that passes, great. This can be refactored and we could come up with the bottom-up dynamic programming solution, but I'm just gonna consider this good enough. See you on the